Hey everyone, Professor Michael Scanlan here with one of my favorite demonstrations. It looks kind of space agey. So I want to explain a little bit of the history behind this one. In 1897, J.J. Thomson discovered what we've come to call the electron. This smaller than an atom or subatomic particle that has what we call a negative electric charge. And he did this and he was able to measure some properties about it. And as with most of these types of experiments, we have modern day reproductions of them that our students in labs actually reproduce and attempt to get the same results. So I have such a setup here, okay? I want to show it to you. And it's going to involve all of the topics we've covered so far. It's pretty cool. I'm excited. Let's take a look. All right. This is what's known as an E/M apparatus, or experimental apparatus. My apologies. It looks, like I said, pretty space agey. It looks really cool. I'm going to move the cover off of it so we can kind of see what's going on here. So, I have 3 power supplies that are required to run this thing. So the bottom one is connected to here, which is these 2 rings. Now these 2 rings have coils of wire. So when I have power turned on to this bottom one, and I have it turned on here, so it's actually got 2 on switches, that's gonna run a current through these circular loops, okay? I know from Oersted that if I have current here, I've also got a magnetic field. And the magnetic fields from these 2 loops are going to add together, and they're going to be strongest kind of in the middle right here where this bulb is. This bulb is free to rotate, as we'll see later. I'm going to actually, when I turn it on, I'm actually going to rotate it. In the center of this bulb, now this isn't a typical light bulb, as you can pretty well guess. In the center of this bulb, I have a little apparatus here. This is, well, it's basically an electron gun. It shoots electrons, okay? As part of it, there's a heater, and I have that connected here to the middle power supply. That's gonna power our heater, and that's gonna excite the electrons, and hopefully excite them enough to leave the metal. My third and final power supply is gonna provide a high voltage. It's only I think about 300 or so volts is what I'm actually going to have it as. So it's not horrible, but it's not something you'd want to touch either. It's going to provide a voltage that is going to take those electrons that the heater is able to excite enough to leave the metal. That voltage is going to accelerate them and shoot them out. Okay? So that's the mechanics of how this works, or the concepts anyway of how this works. This bulb is filled with helium. And when the electrons shoot out of the bulb, they're going to ionize the helium, and it's going to form a plasma. Plasmas are ionized gases. Instead of having an atom, right, I'm going to have an ion. What does that mean? An atom has a certain number of protons in it and a certain number of electrons. When it's neutral, and we call it just an atom, then the number of protons and the number of electrons equal one another. Whenever the number of protons and electrons don't equal one another, that I'll have more electrons and protons and more protons and electrons either way, it's called an ion. And so what the electrons are going to do here, it's going to ionize or mess around with the electrons in this gas. An ionized gas is called a plasma, and that plasma will glow. A lot of plasmas do. Not all of them have to, but a lot of them do. Okay. The hood is just so you can see the glow a little bit better. Now, when I start this off, I'm not going to have these top coils, these 2 big rings of coils turned on. Okay. As we progress, though, I will turn them on, and you'll see the effect that this actually has. This is best viewed in the dark. So I'm going to turn the lights out and probably make my camera go nuts. Let's power on the heater first. And you should see it start to glow there in the center. There we go. So we're noticing a glow there in the center. I'm going to turn on the electron gun. And lo and behold, what do you see? You see a green beam of light. That's the plasma. That's the ionized gas. So this is a beam of electrons that we're seeing. Now you notice it's just a straight beam. I have here with me a magnet, and I want you to watch what the beam does whenever I bring this magnet close. So I'm going to bring the north end of the magnet close to the beam. Pretty cool, huh? Now I'm going to bring the south end of the magnet close to the beam. It's a little bit different. So a magnetic field exerts forces on moving electric charges. So I'm able to kind of drive or steer these electrons using this magnet. Now I'm going to leave the poor things alone and put the cover back on. And now I'm going to turn on those coils. Those are called Helmholtz coils. I'm going to turn on those coils so we'll see what happens here. And as I turn them on, notice what happens. That I form a circle. And if I make the magnetic field stronger, it just tightens the circle up. So I'm making the electrons kind of run in a circle here. I want to show you what happens if I misalign this. So I have it kind of perfectly aligned here as much as possible. I'm going to misalign this. I'm actually going to turn the bulb. I want you to see what happens. And to do that, I'm going to have to move the camera a bit. Notice that instead of just being in a circle, as it is here, there we go. Instead of being in a circle as it is here, if I change the bulb a little bit, it spirals. So a magnetic field on a charge that moves exerts what we would call a centripetal force, and that causes it to change direction. If I misalign it the other way, it spirals the other way. Let's see if we can see it from this side. So here and here. So there we go. A really nice demonstration, one of my favorites because it's just so bright and so interactive. It's just really cool to sit there and manipulate a beam of electrons with a magnet, and you get to see exactly how a magnetic field affects the motion of charges, of electric charges as they move. I hope you've enjoyed this one as much as I have. I'll see you in the next one. Bye, everyone.